Good afternoon, my name is Peter Hack, I'm the founder of RedStack. Please let me introduce to you RedStack, the first spin-off company from Redsys. We're focusing on the development and generation of blue energy. The worldwide potential of blue energy is to generate 1 terawatt of full sustainable, full continuous energy. Please let me explain to you how we're going to do it. Blue energy is the generation of sustainable power by contacting two flows of different salinity. For example, where a river flows into the sea, we can harvest large quantities of sustainable power. RedStack uses the difference in salt concentration between two water flows to generate the sustainable power. We apply ion selective membranes, two different ones, anion selective and cation selective, in stacks to harvest the power. The membranes are stacked alternately into a pile, a stack. The two water flows flow alternately between these membranes. The positive ions in the salt water move through one membrane to the fresh water. The negative ions move to the other membrane to the fresh water, in opposite direction. All pluses to the one end or negative to the other end, a DC power supply. This technology and the hardware is the RedStack, or unique product. In the energy transition, we are introducing and implementing various types of sustainable energy sources, like sun and wind power. They all have one problem: the supply of power is not continuous and often not predictable. No sun, no wind, no power. So we would need large-scale storage and need to accept the high losses and cost of such systems. Please let me further introduce our technology to generate sustainable and full continuous power. Blue energy can be harvested everywhere where rivers flow into the sea, but also can be implemented in flood protection systems, pumping stations and places where brines are discharged into surface water. In the Netherlands, the potential is to generate up to 1,750 megawatts on various locations. On the worldwide scale, the potential is 1 terawatt, or 12% of the world global electricity consumption. Please let me focus a bit on RedStack. Who are we? We are the first spin-off company of Redsys, the European Center of Excellence in Sustainable Water Technology. Our know-how is backed up by the support of Redsys, 18 PhD studies done, and we have a patent portfolio of some 15 patents. We have a significant pilot plant operating in the Netherlands at TRL 7. This was supported by several EU funds. We also have good publicity. Our king, Willem-Alexander, came to do the grand opening, the ribbon cutting ceremony, and we were awarded the title of Dutch National Icon by the full board of Dutch ministers. Let's take a look at our pilot plant in the Netherlands, using seawater and lake water as sources for blue energy. And also, let's go back how it started. In 2004, model calculations made that 1 megawatt could be harvested out of contacting 1 cubic meter per second of fresh water into seawater, and a power density of 2 watt per square meter of membrane could be generated. This was confirmed in the laboratories of Redsys only in 2011, and then we started to build our pilot plant. Our pilot plant was commissioned in 2014, but it lasted up to 2019 before our pilot plant under real-life conditions met the expected performance. Please let me elucidate how and what happened. Of course, clogging was a challenge. I'm not going to say that we do not experience any bio or chemo fouling, you would believe that anyhow, but thanks to the right pre-treatment, the optimized stack design, the dedicated process design and operations, we can state that the fouling is now under control and does not have a negative impact on the performance of the membrane stacks and the power generation efficiency. Let me show you some examples of the cooperation between the Redsys scientific staff, the PhDs and the RedStack process engineers. We developed profiled membrane configurations to prevent the clogging, whilst ensuring good mixing and low hydraulic pressure drop. We applied model calculations in this design to enable us to design and shape the size of the profiles on the membranes to realize the optimal performance of power generation. Upscaling of a reactor is said to be a big challenge. We have been upscaling our membrane modules from small laboratory stacks with only a quarter of a square meter of membrane in the module up to stacks with more than 500 square meters of membrane module. That is 2000 times bigger. We have measured and proven that during the upscaling, the efficiency of the system does not deteriorate. Per cubic meter of water and per square meter of membrane, the efficiency and the performance stays the same. We only have one more step to go to increase the size of the stack in another 4 times, up to 2000 square meters of membrane. We have already designed the stack and the CFD calculations show that there is no risk of losing performance. Our core technology is the process know-how and process design and the membrane stacks, of course. Multiple membrane modules are positioned and connected in frames, and multiple frames are connected in equipment production lines. Let's take a look on the impact on marine life and ecosystems of blue energy plants. The water inlet system and the filtration system can have a negative impact on marine life. However, independent third-parties institutes like Deltares, DIOS analyzed and measured the impact on the marine life of our pilot plant, the TRL-7. They extrapolated it into a model for a 50 megawatt power plant, and the conclusion is that no significant environmental or ecological aspects can be expected on such a large scale, even in the sensitive ecosystem like the Waddenzee, a UNESCO protected environment. That means in industrial applications and harbors and deltas, there should be no problem implementing such blue energy plants. We are now preparing for upscaling into a demonstration size of 3 megawatt, using the same size of membrane stacks as will be used in future full-scale industrial plants. Despite the significant achievements we realized so far, and despite the enormous worldwide potential of 1 million megawatt, I must admit that it was not an easy job to do, and we still are facing some challenges. It's a new technology. It's not yet proven on a very large scale. We are a worldwide technology leader, meaning that we have to pave the road all ourselves. We are heading for the cost down curve, but that will be only after implementing on very large scale. In future cooperation with power companies, consultants, engineering contractors, we can look at the opportunities. The levelized cost of energy is calculated to be only 11 cents per kilowatt hour for the first full-scale 100 megawatt plant, and it will be going down to 5 cents per kilowatt hour probably after 2040, once we have commissioned a couple of full-scale plants. This means that the levelized cost of energy is lower than the power from nuclear systems and also lower than storage systems. Because blue energy is full continuous, is eco-friendly in its power generation. The worldwide potential of 1000 gigawatt, that should be the great opportunity. Thanks for your attention so far. I hope you are now enthusiastic about blue energy and its potential. And if you want to join making a great contribution and a business in the energy transition, you know where to find me, Peter Hack at Redstack. Thank you very much.